All right, mathematicians. So we are continuing our lessons for today. I'm on 3.3. That is on page 20. Okay, so we're going to continue talking about circles and these things called radius squares. More specifically, we're going to, if you read the focus question, what is the relationship between the radius and the area of a circle? Much like the previous lesson where we found the relationship between the diameter and its circumference, we're going to learn the relationship between a circle's radius and its area now, okay? So if we take a look, it says in the drawing below, a shaded square covers a portion of each circle. The length of the side of each circle is the same length as the radius of the circle. So you said at the beginning of the sentence, you guys, the length of the side of each circle, that should be a square. The length of each side of each square is the same length as the radius of the circle. So take a look at circle 1. So they are saying that the side length here is the same as the radius. Do you agree? Well, there's the center of my circle. Hey, look, it goes from the left side of my circle to the center. That's the definition of a radius. I also have another radius right there. There we go. So the radius of this circle is 1, 2, 3, 4, 5, 6 units. So we're going to go ahead and write that in for circle 1. The area of the radius square. So the square that's created by our radius, I'll highlight this, or I'll outline it. There we go. This purple square is what we call our radius square, right? Because the length of the side of the square is the same as the radius. So what is the area of this radius square? Well, we said it was a 6 by 6 square. So the area, 6 times 6 is 36. Okay. Now, we're going to try and use this radius square to help us find the area of the circle. Okay. Do notice, however, you guys, that the radius square can only account for so much of our area. Right? I mean, there's quite a big portion of the square that's outside of the circle there, okay? So keep that in mind as we're doing this. So what I'm going to do is I'm going to draw some more radius squares. So I'm going to draw another one over here. Just like that, okay? And so I have another 36. I think I can fit, yeah. I can definitely fit more. Now, to spare you guys having to count the actual squares, we're going to do our best to approximate here, okay? Ooh, why did I do that? We're going to do our best to approximate the area here, okay? And again, you guys will notice that it's not perfect, right? These radius squares are not exactly equal to the area of my circle. So I have to ask you guys this. Approximately, how many squares do you think it takes to fill up the circle? How many radius squares would you say? So take a moment, pause the video, ask someone around you, how many squares would it take to fill up the circle? All right, hopefully you pause the video, hopefully you talk to someone. If you said 4 squares, the area is going to be overestimated. Okay, so 4 squares is way too much for the area of the circle. If you said 3 squares, 3 squares actually is not going to cut it. It's going to be, the area is going to be underestimated. So you're probably asking, or you're thinking to yourself, Mr. RG, if it's not 3 and it's not 4, then what could it be? Well, I'm going to say, is there a special number that's in between 3 and 4 that we've talked about when we talk about circles? Oh yes, that pesky number pi. You guys will notice that we need a pi number of squares to cover the exact area of the circle. For our minds, we're not going to write pi in this column here where I'm starring. We're not going to write pi here. We're just going to say a little more than 3. A little more than 3 squares are needed. And then if you want, in parentheses, we will write pi, right? Because that's the exact number, but that's a little strange, right? How many squares do you need? Pi doesn't really make sense, okay? So we'll just say a little more than 3 squares. So let's go ahead and find the area of the circle. So if I do, I know that 1 square is 36, so I'm going to go ahead and multiply that by 3. So that's 18, 3 times 3 is 9, plus 1 is 10, so that's 108, right? And I know it's going to be a little bit more, so we're just going to approximate. So we're going to say approximately around like 115 or so, right? Just do your best. I promise it'll become more exact once we figure out the formula, but for right now, approximations are always good. Why am I writing in pink? I should be writing in purple. Okay. Let's go ahead and do the same thing for circles 2 and circle 3. You guys will notice, before I let you guys go, that you'll need a little more than 3 squares for each of these to cover them up, or to find the surface area, okay? So I'm going to go ahead and write that in for you guys, a little more than 3, or pi squares. Okay, so go ahead, pause the video, work on circle 2, work on circle 3, approximate the area, okay, and then we'll go ahead and move on to our next page. Okay. Hopefully you paused the video. I'm looking at circle 2. So my radius for circle 2, I believe, is 4, right? So therefore the area of the radius square is going to be 16. Because it's a 4 by 4 square. Just like that. Okay. So the radius of the circle is 4 units. The area of the radius square is 16. So I'm going to take 16, I'm going to multiply it by 3. 18, 3 times 1 is 3, plus 1 is 48. So I'm approximating probably around like 52 square inches. Okay. Somewhere around there. We'll see once we figure out the formula. Let's go ahead and do circle 3. Circle 3 has a radius of, whoops, let me do that again, a radius of 3. Just like that. And then that makes the area of my radius square 9. 9 square units. So I'm going to multiply 9 by 3, so I get 27. But I know it's a little bit more than 3, so I'm going to say like 30, 31, maybe 30, approximately 30 square units for the area. Okay. Now, let's take a look at question number 1. It says to describe any patterns or relationships you see in the table that will allow you to predict the area from its radius square. So take into account the things that we multiplied to get our approximation for the area, right? That's the only hint I'm going to give you. Think about what are we multiplying to get our area, or the estimate we got for our area, okay? So think about it on your own, talk to a partner, pause the video, do these things now. All right, hopefully you paused the video. Let's talk about it. So we know that we started with the area of our radius square. Okay, so I'm going to say the area of my radius square, okay, and we multiplied it by something. We multiplied it by, well, if I look up here, I multiplied it by 3, but then I needed to multiply it by a little bit more, right? There's that specific number that we always talk about when we're talking about circles. Yes, we need to multiply this area of our radius square by pi. Then this gives us the area of our circle. Well, let's rewrite this. Let's rewrite this in a more mathematical sense. So what's nice about this is there's a little bit of a parallel for radius square when we write our formula for area. So what we're going to write is, I'm just going to draw an arrow down because this is literally what we're doing. We are taking the radius and we are squaring it, hence radius square. You're going to multiply that by pi, so that doesn't change, and this gives you the area of your circle. How can you find the area of a circle if you know the radius? Square it, multiply it by pi to get the area. And boom, there we go. We have an area formula for a circle. All right, let's keep going. We got one more. How can you find the radius if you know the area of a circle? I want you to try this one on your own. Pause the video, try and figure it out. Okay, let's talk about this. So I'm going to rewrite my area equation. So area is equal to my radius squared times pi. Now I want to find the radius from this formula, right? If I know the area, can I work backwards to find my radius? So I need you to think about, what are we isolating? What variable are we isolating here? Well, we're solving for the radius, we're looking for the radius, so we should isolate r. Let's get rid of this pi first. So r squared is being multiplied by pi, so in order to get rid of pi, I'm going to divide both sides of my equation by pi, right? So my pi's on the right side go bye-bye, and now I'm left with r squared is equal to the area of my circle divided by pi. Now here's the tricky part. I need r is not by itself just yet, right? There's still that exponent of 2. I need some way to get rid of that. And don't say divide by 2, because dividing by 2 is a very different process than what we need. So because we are squaring r, we're multiplying r by itself, we are going to take the square root of r, right? This fancy looking division symbol. It's not a division symbol. I don't know why I said that. It's a square root sign, okay? We're going to take the square root. And what this does, what this symbol does, is it actually gets rid of that exponent for us. So the square root and the exponent cancel each other out. So we are left with what we need, which is r. And now you're probably asking yourself, well, what happened to the left side? Well, the rule still applies. What you do to one side of your equal sign, you have to do to your other side. So my left side, before I took the square root, was that area divided by pi. Then I took the square root of my right side, so therefore I must take the square root of my left side. So to find the radius, I have to take my area divided by pi and then take the square root of that. Once I do that, then I get my radius. Okay, so really quick, I want to take a look at this. So for circle 1, my radius is 6, so I'm going to square it. All right, 6 times 6 is 36. And then I'm going to multiply that by pi. And I get approximately 113.1. My approximation at first was 115. I shot a little high. That's okay. let's check the next one. My radius squared is 16. I multiply that by pi to get 50.27 approximately. 50.27. Again, shot a little high, but I was pretty close for estimation. And then the last one, my radius is 3, so I square it to get 9. I multiply 9 by pi to get approximately 28.27. Again, a little high for my estimation, but I was still pretty close. So there you have it. You now know how to find the area of a circle. Okay, congratulations. You made it this far. You have completed all the lessons you needed to for today, so you may go ahead and take a look at your homework. All right. Please let me know if you guys have any questions, and I will see you in the next video.